stand wherever, it doesn't matter. All right, here, hold this first. I'm going to give this to you. All right, let's go and get started. I'm going to work on getting all the tech and whatnot set up. Sorry for getting started a little late. I guess maybe the rain's slowing us all down today. So a couple things. I usually have an intro slide, but for some reason this computer is failing to have an internet connection this morning. So I had that on my network drive, but I'll try and remember a few announcements. Just remember that the okay, I guess my screen's loading and whatnot. Just remember that the mechanical engineering student organizations and the civil engineering student organizations are still having their meetings and whatnot, so try and attend those if you're interested. I did want to bring up a couple points. So starting next week, and we'll have, I'd say about, I think, 3 presentations, but starting next week, we're going to have what I would call some Marshall-themed presentations, things on like career services. We're going to have a big registration presentation so that you all know a little bit about signing up for classes, how to figure out who your advisor is and whatnot, some other opportunities within site. So if you, I would argue, you really want to come to those because it's really going to be beneficial. Of course, I want you here every week, but I did want to emphasize those. Lastly, the Civil Engineering Student Organization, SAME, ASCE, they're organizing a tour of the Bluestone Dam that's going to be taking place on Friday, November 4th. I think that's the day. Now, this is one of those things where the sooner they get your name, the better, because they need a list of names for the tour. So if you're interested but still not sure if you can make it, go ahead and send your name in, and then if you've got to drop out later, no big deal. It's a whole lot better to get your name on the list now as opposed to later. All right, and you'll want to send that to morgan268@marshall.edu. So you might want to write that down. I'll have some stuff uploaded to MU Online with a few more details. But if you're interested, go ahead and get your name on the list, and then if you've got to drop out later, no big deal. Sound good? All right. So just like always, we're going to have 2 speakers. Our main speaker is Doug Kirk, who's an H&H engineer with the DOH, and he's going to talk to you a little bit about what he does there. But right now, we're going to have a faculty come in and introduce themselves. This week, we have Dr. Iyad Hijazi, who's a faculty in mechanical engineering. He's going to tell you a little bit about what he does. So everybody, let's give a round of applause for Dr. Hijazi. I'm going to get the lights adjusted, so they'll turn off for a second, but it'll be all right. And there we go.
Yeah, let's see the best.
The floor is yours.
Okay, hello. I'm Dr. Iyad Hijazi. Probably some of you know me already. Assistant professor here, Department of Mechanical Engineering. My field of study is material science, but specifically my area of concentration is in nanomaterials. My education, I did my BS master's degree at Kansas State University, my PhD at New Mexico State University, and you can see my GPA went up from 3.3 to 4.4 when I finished. So it was really interesting time, especially at New Mexico State University. So but when I finished my BS, my master's degree from Kansas State University, I went back to Jordan. My mom and dad missed me, so I went back there and I worked. My first job was with the Jordan Pipe Manufacturing Company. Basically, I was the head of the import section. I was the only person in that department. And my job was to purchase materials, equipments, and spare parts, make sure they have all the, these needed materials, and doing a lot of correspondence, looking for good vendors, and doing all the banking transactions and so on. So I did this for a while. This was my first job. Then I found a better job as a fire protection engineer. I did for a small company. And so I did this for a year and a half, designing sprinkler systems using AutoCAD and other systems, hydraulic systems, software to calculate the needed pumps and pipes and so on. And I did this for about a year and a half or so. And then I got a job with the Royal Scientific Society as a design engineer. So that's got me closer to my area, especially that my master's degree was in the area of computer-aided design. So I was very good with 3D graphics and so on. So this was a little bit closer to what I like to do. So we were designing plastic molds, and we had 2 teams, one doing the designing and the other one's doing the manufacturing. Once we generate the CNC code, it's their job, and of course we have to make sure that everything is done to specs. Then I got a better job at, in Athens. Was really interesting for 8 years as a senior automation engineer. Basically, as a senior automation engineer was basically to make sure that all the engineering software they use in their projects, that we can support, do training, and go to the to their construction sites. But I really didn't like that. I'm not a site guy, so I got my way out of it by convincing them to create a 4D navigator, basically taking all these drawings that we get from our suppliers, our clients like ExxonMobil, Chevron, British Petroleum's, Chiyoda. So all these drawings are coming in microstation format. So what we did, we created a 4D navigator, reading these drawings and being able to view them in this 4D navigator where we can do color coding, look at okay, what material is needed, what material is missing, and so on, do queries basically, and connect it to SQL servers and planning, like planning software like Primavera. So we did this, I did this for a couple of years, and then really the software is still used. It's actually commercially. It's available commercially, and really that was very interesting, exciting time for me for those couple of years. And then after that, I decided, after living for 7-8 years in Athens, we decided to come back to the States, me and my wife, and we both went back to, we got PhD in New Mexico State University. I did mine, she did hers in agronomy. And so after graduating from there, I got a job in Saudi Arabia. We'll talk about this. So here at Kansas State University, so my academic experience really starts when I was a master's student. That's the first academic experience that I got. And I started as a graduate research assistant, working with computer-aided design. My thesis was entitled feature-based, an object-oriented feature-based design methodology for the creation and manipulation of 3D solid and alternative geometry. So that gave me really a solid background in 3D and in CAD, which really helped me in my career at CCC. And then I was a teaching assistant for, I did some grading for thermodynamics, helping the classes, and then also as a research assistant, I got also funded. Then at New Mexico State University, I was a teaching assistant for here, graduate. Okay, I was a teaching assistant for a while, also a research assistant. So part of my job in the beginning, I was doing something related to pyrotechnic valves. And we did this using finite elements. I did this for a year and a half. Then I decided to switch to nanomaterial, which was more exciting for me. And so I did both teaching. I did some teaching in the computational physics lab, and also I did something, I don't know what I put in the slide. I did something also teaching with the capstone project. I did this with the capstone project also. I was a teaching assistant for the capstone stuff. So using NX software, helping the students with their capstone projects and other activities related to their capstone project. So basically, my teaching also experience started also as a PhD student at New Mexico State University and also at Kansas State University. Then once I finished my PhD was in the area of nanomaterial, of course, coming with models for materials. So we come with these models, and then we use these models to study the properties of materials. At Georgia Tech, I continued my research, but now we did it with zeolites material, studying the absorption and diffusion of small molecules in flexible framework. Usually most of the simulations are done with a rigid framework where the body of the zeolites is fixed, and they just study the diffusion and absorption of the molecules in a rigid body. So my job was to reflect the flexibility and to see how absorption and diffusion it changes with the flexible framework, where we're allowing the zeolites to vibrate, the atoms to move at different temperatures. Then once I finished my postdoc, I did a postdoc for a year. I got a job as an assistant professor in Saudi Arabia with Prince Mohammed bin Fahd University. And really, this university most of the instructors were coming from different countries, from Germany, from US, from Australia, and England. And the curriculum was adopted from, actually from Texas. A consortium of universities developed the curriculum. So I taught materials engineering, corrosion, introduction to manufacturing systems, manufacturing methods and design, computational methods, and ME Lab 2. Then I applied to Marshall, and we moved here in 2013 as an assistant professor. I'm still here, and so far I have taught also the engineering profession, engineering computation, CAD, materials, advanced engineering 1 and 2 now on the master's level, and corrosion. So these are the last 2 courses are courses on the master's level. And of course, I have a lot of things to do as an assistant professor, teaching, advising, writing proposals, continuing my research. I have 2 right now, a master's student doing her thesis with me, and another one starting his research with me. So I have 2 graduate students actually intending to do a master's thesis, not report. And then my research so far, as I said, my research is in the area of nanomaterial. And really, this is an exciting area of research, especially when you use numerical. I don't know, experimental maybe is also exciting. But numerical, you can see things quickly. You run the simulation, you see the results, and then you can publish papers. So basically, nanomaterial, why it is interesting, because just like I would talk in my materials class, the way you process the material, you'll have different structures will have different properties, and different properties will have different performance. So you can study a lot of properties, mechanical, thermal, electrical, magnetic, optical, and so on. So, and of course, with the nanomaterial, you're designing things from the bottom-up approach. And as I said, you can study all these different types of properties. So this is really an open field, and it's multidisciplinary field in many areas. So whether it's in electronics, medical, or engineering sector, really has a great, fantastic future, an exciting area. And here's an example. I took, like this is a 38 atoms of gold, and just by changing, of course, running the simulation, once I come up with those models, the interatomic models that I work on, I can run simulation, and here in this case, looking for low energy structures, and in one of them, 1 atom of copper replaced a gold atom. Next one is 2, 3, 5, 6, and they start having interesting properties. One of these properties, we know that conductors, they don't conduct electricity, excellent conductors. Something called the Fermi gap. In insulating material, the this Fermi gap is very large. In metals, it's non-existent. In semiconductor material, it's halfway. So here what's interesting, that we can see that number 1, AU38 and CU38 has good magnetic properties. The gap is okay, it's like a metallic. But what's happening here, that we start having, but the gap is a little bit large between, almost like an insulator, kind of, like it's still a little bit big, especially in the case of CU38. In the case of AU38, it's non-existent. So here we can see that with 6 atoms replacing 6 atom of gold, we have excellent magnetic properties, and what's something new called half metal, meaning that this one is a metallic, this one almost like a larger gap, almost acting like a semiconductor. So this is a half metal and also have a magnetic property. So that's the type of things that you can do with nanomaterial, finding new material with interesting properties. And in this case, just by replacing few atoms, you have different magnetic and electrical properties. These are some of the publications that I did since I got here. This paper was accepted. This one, we submitted, they accepted, but with some edits. We're working on it. And once, if I'm successful with this one, now I'm doing it with palladium hydride, which it has applications in gas storage and in coal gasification, where we can get gas, break the coal into small molecules and atoms, and then we can has a selectivity for hydrogen, and it can trap other molecules like CO2 or H2S and so on, and we can filter the hydrogen. So if I'm successful with this one, that opens the door for me to do it with other metals as, for example, let's say nickel and copper, and then mix them up, create alloys of amorphous materials, for example, that has excellent selectivity for hydrogen and can withstand high temperature that can be operated in the gasification process. So this is basically what I do here at Marshall, teaching courses, doing research, writing proposal, and helping students. And it's a nice area. And also, the last thing, I got some awards for my paper in 2010. I got an outstanding technical award for the simulation. I used Monte Carlo simulation, and they really liked my technique. And also, I got some awards when I was at PhD, doing my PhD. And finally, it does really pay the more you are educated, as we talk about in the introduction to the engineering profession, the more you have education, the better pay you get, and the less unemployed you are. So education pays, and really knowledge is interesting, and science is fantastic. And that's it. Okay.
Anybody have any quick questions for Dr. Hijazi? All right. Thank you very much. I'm going to go ahead and turn it over to our main speaker, Mr. Kirk. So everybody give him a round of applause.
But I took the longer answer, huh? Sorry about that. All right. Okay, you need this one,
I need
and this one.
All right, thanks. Well, it's a little bit intimidating coming to this big theater with all these students here. I'm used to talking to smaller groups, usually at West Virginia Tech. The school I went to was University of Missouri at Kansas City, and only the freshmen, well, I guess this is a freshman class. We didn't have too many big classrooms like this, so I'm excited to be here. I'm excited to see so many young, smart folks ready to go into engineering. This talk is about you. It's not about me. So if you have questions, feel free to ask. I'm here to help. So hopefully I can give you a little bit of insight into where you're going to. Are most of you civil students or mechanical? Let's just see. How many civil students do we have? How many mechis? How many electrical? Industrial? Aerospace? Bio whatever. Okay. All right, so mostly civils. When I first started, I was going to be a civil engineer, and then when I found out a few mechanical engineers get to do what he just talked about, I figured I wasn't going to be one of the few. I was going to be one of the many that was doing HVAC systems or plumbing designs. And I said, at least civils get to work outside a little bit. So I decided to go with that. So here we go. So civil engineers get to go all over the place. Just a few pictures from places I've been and places I've worked. On the upper left here, who recognized that airplane? Bueller? Nobody. So that's a U-2 spy plane in Korea. I didn't have anything to do with the plane except I helped build the hangar behind it. Upper right is, I did get to watch it land one time. That was a lot of fun. Upper right is a bridge in North Carolina. If you've ever been to Asheville, I-26, the A-10 connector, that's a Little Creek Bridge. And I was on survey crew down there and got to climb up and down those mountains setting backsides in the snow. It was a lot of fun. Fortunately, Mount Fuji, when I went there, was not snowing, so I got to climb it. And has anyone ever heard of Knob Noster, Missouri? No. Well, it's the state park right next to the base where they keep the B-2 bombers, and I spent some time there as well. So civil engineers do a lot of different things, and here's like a formal definition. But in this picture, you can see so many things that that we do work on. And right here's a water treatment plant. Here's a couple of bridges. Here's a railroad bridge. Here's a street bridge over here. All kinds of buildings, baseball field. If any of you guys end up coaching Little League or whatever when you get older, your engineering skills are going to come in handy because you're the one that's going to be asked to lay out the marks, for the fields, because no one else will figure out how to run a 3-4-5 triangle or anything like that. So the other thing here is the river. or the lake formerly known as the Elk River, is controlled by a dam. So you don't see a dam in the picture, but it has an effect on what you see. So fun with math and science. Typical engineers, you guys probably had about 30 on your math and science, and maybe about 20 on your English. So you're going to get to do a lot of math and science. So that's a lot of fun. So let's see. Career opportunities. There's always jobs for civil engineers. You know, there's always roads and railroads and buildings that either we need to build new ones or we're trying to fix the ones we've already got. So you always have a job, but Dr. Hijazi's pay scale was a little higher than what we might expect. But that's okay, because we'll be working. So there's two career paths eventually. Now right now, you know, we'll talk about school a little bit later, but once you get out, you'll start and you'll be a techie. You know, you'll be doing the math and crunching the numbers and drawing the pictures and everything, and that'll be fun. That's really the fun part of it. As you get older, you reach a point where you have opportunities to go into management, and some people are management material and some people want to stay engineers. So consider what you like to do as you start to work your way up. And you know, I've read that a lot of engineers don't even work as engineers, but they find that you guys will have good analytical skills, you'll have good work ethic. So you'll be able to work in about anything you want, even if it turns out not to be engineering. So some of our projects are really exciting. Who recognizes the bridge on the upper right? Just shout it out. Proctorville, okay, very good. How about the one on the left? New River Gorge, all right. So you know these are famous bridges, they're exciting. But some of them are not so exciting. Nobody recognizes the Alton Bridge, and this thing is really kind of a mess. And I'm not a structural engineer anymore, but you know, what supports the bridge? The things at the end, right? Well, if you look right here, that's the connection of the beams to the abutment. So actually, it's held up by these really scary-looking bents. We drove across it before we saw under it, and I probably would have walked or swam the Buchanan River instead. But so that's kind of an interesting thing. This is another crazy one here. So we're standing in a 10 by 10 box culvert. When I took this picture, the outer edge here is a 6-foot diameter pipe, and we're looking downstream, flowing into a 4-foot diameter pipe. So it's like a funnel, and that kind of works and it kind of doesn't, because you size it based on the entrance. But if you get smaller as you go down, you're going to have trouble. And the other trouble was there was no transition, there was no seal between here. So the reason the road above was falling in was because the soil here was falling into the pipe and getting washed into the river. And this, I think, is a water line or something that the neighbors put in. What you can't see is this isn't all mud, and up where I was standing there was little bits of paper. So it's kind of a mess that we got into. So here's a nicer place to work. So as an engineer, how many of you guys want to work outside? You think you want an outside job? Okay, well, a lot of engineers do work outside, and some get to work inside, but most get to do a little bit of both. And I have an office, that's primarily where I'm at. Probably once a week I'm in the field and I get to go out to the rivers and creeks and bridges and highways, and that's fun. So that's the kind of thing, if you haven't decided yet, being a civil is a good place to start, because eventually you'll have the opportunity to choose. A little bit about the highway department now. There's 38,000 miles of roads in West Virginia that the highway department is responsible for. And it's a pretty small state. You know, everybody says, well, West Virginia is 50th in everything, and that may be true in some statistics, but we're among like the top 4 or 5 highway departments in terms of road miles. And the reason for that is we have no county roads, and most of the city streets anymore are taken care of by the highway department as well. So pretty big operation, almost 7,000 bridges. So there's a lot to do. We have offices all over the state, county maintenance garages everywhere, but we're divided into 10 district offices, and you'll see there's one in Charleston, Huntington, Parkersburg, Princeton, Bridgeport, Clarksburg area, and Burlington. How many people know where Burlington, West Virginia is? Yeah, I didn't either until I drove through it trying to find the office. And you go down one hill and up the other and you've passed it. And it's a small town out in Mineral County, but they take care of the Eastern Panhandle. So we're all over the place. If you end up in the central office, which is where I'm at, there's a whole lot of variety of things you can work on there. We have a planning division, and they just try to scheme about, you know, what the politicians might want to build next, and they try to come up with vague ideas of how we might accomplish that. Engineering is where I've spent my 20 years at the Highway Department, and it's pretty good. You get to apply what you learned in school, a lot of math and a lot of science and fun like that. Traffic, that's fun as well. And of course the right-of-way division is just trying to figure out where we can build the road and whose land we're going to take. Contract administration, materials, more about like Dr. Hijazi was talking about, steel and concrete and such like that, and maintenance, trying to take care of everything. And of course the multiple bureaucracy divisions. All right, so just a little bit about me. I spent my first 2 years in roadway design, roadway geometry, figuring out how wide the road should be, how thick the pavement under it needs to be, and where it should go, and how to drain it. Then they transferred me to the consultant services section for a little while. I lasted about 10 months in there. It was fun. I got to meet a lot of interesting people and talk about interesting projects, but I really wasn't doing engineering work, and I didn't have my license at that point, so I wanted to get back to design. So I went to structures for about 3 years, and that was a lot of fun. But when I realized that the longest bridge that I had designed as far as its span was shorter than the width of some of the other bridges that we're working on, I'm never going to be a famous bridge engineer, so maybe I should try something else. So hydraulics opened up about that time, so I went there and got to work on a lot of different projects, and it's been a good experience for me, and more outside. So here's the 10 districts that I mentioned earlier, and you can see which counties are where, and make sure this is on the quiz, right? Okay. You all had West Virginia history in 8th grade, right? Yeah. All right. So the range of projects I've worked on is simple ditch design to some of the longest bridges in the state. Who recognizes this bridge? You ever been to Parkersburg? It's a Blennerhassett Bridge, so it connects Parkersburg over to Belpre, or a little bit downriver from there. Okay, bike paths to interstates. Some of the mitigation that we've done, so when we build a road through a national forest, they say, oh, you're damaging the forest, so you need to bring us a shrubbery or something like that. And they'll, so they ask us to build bike paths through the national forest, so we've got a bunch of those going on. But I-64 here keeps us pretty busy, and as I mentioned before, some of us work in the office and some in the field, and if you're fortunate, I think you get to do a little bit of both. And even if you get stuck in the office, convince your boss or sneak to the field and get to see the things that you're building and things that you're working on, so that you can get some feedback from the builders that say, well, you know, this is a good idea, this wasn't such a good idea, and you can learn and grow from that. So functional areas, design, you can design roads or structures. Geotechnical and hydraulics is a bit, we're kind of like support, because it's all about the roads and bridges at highways. But if it washes away because your hydraulics were bad, or if it falls down over the hill because your geotechnical wasn't good, then you're going to have a problem. And of course, in engineering, we just draw the pictures and somebody else has to build it, so we have construction. And then eventually someone else will take care of it in maintenance, and then planning tries to figure out how to do it better next time. I thought this was an interesting picture here that I found traffic-wise. So this is a roundabout. Have any of you ever driven in a roundabout? Yeah, okay. So we've got a few of those in the state here. And I heard that sometimes when you enter a roundabout, who has the right-of-way? The person going in or the person trying to get out? Trying to get out, right. So that was a mistake they made here. So you see this line of buses? They just came in from right here, and they have the right-of-way over these people that are trying to get out. So eventually, you have total gridlock. You know, this is 4 lanes on each leg, and you've got about 8 lanes in your roundabout, but it's So if you ever design a roundabout, make sure that the people trying to get out have the right of way. And you know, if you're in the office, you're going to do a lot of calculations, have time for creativity, and you'll do a lot of computer-aided drafting and design work. Construction and maintenance, coordination, you got to work with a lot of other people out in the field, deal with concrete, and pretty soon it gets cold. So those are kind of the trade-offs. So my office is in the engineering division in downtown Charleston, and as you can see, we're right across from the ballpark, which is kind of nice. We'll go in and go take in a game in the afternoon sometimes. Most of the central office is over by the Capitol, and the view of the Capitol building here is from the Highways building, so that's pretty nice. We were exiled from there because some other folks needed our office while theirs was renovated, so they sent us down to a building that was supposed to be torn down for a parking lot for the district, but that's okay. We're fine there. And this is Burlington. This is the District 5 office out in the Eastern Panhandle. So if you want to start your career at the Highway Department, the first place to start is as a co-op. And opportunities for that will come up in the summer. You can apply by mid-February is usually the deadline, and your advisors here will warn you of that. You can also apply online, so that's a good thing, but I've got a picture of the application, so when you find it, you'll know what you're looking for. And these are just some young students. Well, they were young then. Some of our co-ops, actually 2 of those work for us now, and the third one works at HNTB out in Taze Valley. So a good place to start. And they do actually pay you better than McDonald's now. Right after your freshman year, $11 an hour, so that's not a lot better than McDonald's, but it's nicer work. After your junior year, the pay is $16.50 an hour, so that's not too bad. That's actually more than I started when I was out of college, so I'm kind of jealous. Make sure when you fill out your form, you say where you want to work, which area, as far as location, and also which discipline you want to be in. Starting out, they'll probably put you out collecting weight tickets from asphalt trucks, but that's good. You know, you got to be out and see that stuff. If you get a chance to be on survey crew, that's fun as well. And it's summertime, so you want to be outside. And there's plenty of office opportunities in each of the 10 districts and also in the central office as well. Of course, in engineering, I'm partial to that, so I would recommend that you try that. I feel like that's going to be your most analytical work that you're going to get to do. But you need to do some field work and some analytical work in the office as well. All right, step 2, after your junior year, or I'm sorry, after your sophomore year, you can apply for a DOH scholarship. And this will just about guarantee you a job if you graduate at the Highway Department, and it'll help pay for your school as well. So apply online. You can Google the application, and that's something you might want to consider. So step 3, before your last semester, when you're about to graduate, then that's when you want to apply to be a highway engineer trainee. And there's the link, but if you just look for West Virginia Division of Personnel jobs, you'll find it, and we'll be back to talk to you guys probably when you're seniors, the half of you that are still civil engineering students. So here's a couple of free ideas. Coming over here, I was thinking back to my freshman year of college. I started at Parkersburg, and if I had followed this list, I probably would have graduated sooner. But sometimes the professors say, here's the homework assignment. I'm not going to collect it. Do it if you want. Does that tell you you should do it or you should not do it? You should do it because they know that the homework is the best way to prepare you to take that test, and that's what they're going to grade you on. And you can think, well, I can spend time doing something else instead of this homework because he's not even going to grade it. Well, they're going to know if you did it, whether they grade it or not. Take notes. I think most of you probably have technology. I see a few of you writing, so that's a good thing. But it seems that physically writing with a pen or a pencil really helps to imprint it on your brain, because you can't write as fast as most people can talk. So you're going to have to kind of process and translate it in your brain a little bit, and that'll help you absorb better. Writing and speaking skills. In college, you think it's all about math and science. It's all about math and science. Eventually, you're going to reach a point in your career, and you're going to say, man, I do more writing and talking than I do math and science. So start now. When you get your sophomore speech class, really work hard in that class and really try to do a good job and develop those skills. Public speaking is pretty scary for most of us. So it's a learned skill, and you can learn to do it and do well at it. Steel bridge and the concrete canoe. Get involved in those projects. And the Meckies have, they build some kind of dune buggy or race car or something like that. Get involved in those projects, work on them, build them, be in the competition. That's a great experience and good opportunity for leadership as well. And enjoy your experience here. I guess you guys have a football game tomorrow. So, you know, do the college thing, have the college experience, but make sure you have your priorities right. Make sure your priority is in the classroom and in the library and on your homework. And the fundamentals of engineering exam. You probably haven't been exposed to this much yet, but they've already talked to you. Okay, so did they say take the test as soon as they'll let you? Yeah, because when kids come and apply, and I've got their application, my first question is, have you taken the FE? And if they say no, well, that immediately knocks them down a notch. You know, it's not essential, but it shows that you're on the path, that you're on the path to being a registered professional engineer. Mechanicals, it seems like it doesn't really matter for them to be registered or not, but civils, it's essential. If you're not registered, you're basically a technician. And that's great, you know, being a technician is great. We need that niche of our profession as well, but you come here and you go through calculus and you go through physics 2 and all that stuff. You've worked too hard to not follow through and finish up and get your registration. So, you push some magic buttons here. We just, okay, bring the lights up a little bit. I want you guys to talk, because like I said, this talk is not about me, it's about you. What questions do you have? What are you thinking about? Why did you want to be engineers? And has anything surprised you yet? We're not going to lunch early, so you may as well start talking. Yeah, go ahead in the back. Like favorite project or type of work? Favorite project. The Blennerhassett Bridge was pretty fun. Some of the stream restoration work that I've done has been pretty good as well. One of the amazing things is just seeing these big earthwork jobs. If you guys have been to Logan, we're building a 4-lane highway from Logan to Man. And the mountains there, it basically looks like this room. Okay, you got a flat bottom that's about as wide as this room, and then straight up. So we're going to come on the side of the wall here, and we're going to cut a notch in that wall and put a highway on it. So that's amazing to see. So really, I guess the big bridges that we've worked on, and those crazy earthwork projects. Corridor H from Weston over to Wardensville, and also Corridor L, which runs up through the middle of the state from Summersville on up.
I have a question.
Yes, sir.
Have you had much work recently with the flood efforts and whatnot?
Okay. No. What I found at the highway department, and I'm trying not to be too sarcastic here, hydraulics has nothing to do with flooding. So I'm the hydraulics engineer, and you'd think, and I just went to a conference out in Oregon, and they talked about how the other states, when they had flooding, this is how the hydraulics people got involved. Really not at all. One of the consultants who was working on a repair job up in Clay called me to come out there, and then he got in trouble. He said, wait a minute. You can't have those hydraulics people out there. We don't need engineering in this. We just want to build it. Well, if you build it without engineering, then you're going to get to build it again. Because if you don't make that bridge bigger to handle the flood, it's going to wash out again just like it did the last time. And if you don't make your pipes as wide as the creek, they're going to wash out again. and you're still going to flood your neighbors, and they're still going to sue you. So, yeah, you kind of hit a nerve there. Sorry. Yes, sir. Yes, it is. Like I said, the pay I think is $11 an hour, but those are certainly available. And we try to employ as many of those as we can, and we'll try to put you where you want to be. Hopefully we can put you where you live or where you can live cheaply, because 11 bucks an hour, if you're just saving that money to pay for college, that's pretty good. But if you're trying to eat on it and live on it, it's tough. So we'll try to put you where you need to be. Apply as early. You know, don't wait until the last day or afterwards and say, Dr. Michelson, can you turn this in for me? Do it as early as you can. But yeah, it's certainly available to freshmen.
And one thing, let me add to that. I mean, I can't emphasize enough how having more stuff on your resume will help you out when you're a senior applying for a job. You know, if you've got two folks applying for a job, and she's got internship experience at different organizations, different industries, he doesn't. What do you think they're going to decide? You know, so that really matters, and the earlier the better. The more stuff you can do, the better.
And, you know, all work experience is valuable. I know when I was in college, I thought, well, I don't want to put, you know, that I worked at Taco Bell and stuff like that. But showing that you worked during college or before, or at least summers, to me, that's worth a few points on your GPA anyway, because I know if you're spending time working, even if it's not relevant work experience, it's still work experience. And right now, you're being asked to do really complicated things in your math classes and everything. Once you get to work, there's not too many days where you come in and you're going to do something you've never seen before like you do in college. It's more about what is your work ethic, what are your habits, do you stay on task, do you show up on time, do you work well with others. So that other extraneous working experience is valuable, even if it seems like it's beneath what you're pursuing.
And one thing I want to add to that, you mentioned that had on a slide that build a bridge out of the canoe, and that is incredibly important. One thing that you'll find any student who's done that or done any work, you know, in the engineering field will say it is fundamentally different, you know, designing something versus what's done in real life. You know, just ask the folks who built the bridge. You know, they draw up this nice, pretty bridge, and it's got the members and bolts everywhere they want it, and then they go to cut steel and weld stuff together, and then they find it's not quite working out the way they thought it would because things change. And having that real world experience, I mean, there's nothing like it. There's no substitute. There just isn't.
Now, you can draw anything, but sometimes it's hard to bolt it together. Yes, sir. You could be in building 5, you could be out in the district, and if you're in a district, you might be in the office or you might be on a construction job. We put a lot of co-ops on Route 35 in Putnam and Mason County, and also down on Route 10 there'll be co-ops out there. Yes, sir. Okay, so you'll be helping the inspectors to try to make sure that the contractor's following the plans, and that means, you know, taking measurements and watching what's going on, and also, you know, they do collect weight tickets and make sure that if you told me we're supposed to pay you for 100 yards of concrete, that we have documentation that you really place 100 yards of concrete. And you'll get to see how it really comes together out there. Yes, sir. Yeah, so you can put what area you want to be in, you know, what county, or, you know, if you know the districts, you can say which district, or even the town. You know, they'll figure it out from what you write, but put where you want to be, and if you know by this point what your emphasis is, which you probably don't, then you can write that as well. You know, write, I want to work in engineering, I want to work in surveying, I want to work in maintenance.
Good stuff. Anybody else? These are good questions to ask. One point I do want to make, though, now that I think about it, when we get, you know, any of these types of opportunities she'll email blast the entire engineering division. You know, here's this co-op opportunity, here's this job opportunity. Make sure you're paying attention to that. I know it's tempting to get a lot of stuff. Oh, that's junk mail. Oh, that's junk mail. Yeah, and in that email might be an opportunity for your future career. So make sure you're paying attention to that stuff. That's really important.
Now, a question you had in the back about what was my favorite project, you know, when you asked that, I was thinking physically, you know, was it this bridge or that bridge or whatever, but probably the most rewarding thing that I've had the opportunity to do is to try to figure out things that somebody else hasn't yet. You know, just that creativity of here's the situation, we've got to do something here, how are we going to come up with that? So whether that's just a different way of looking at it or developing different spreadsheets and stuff like that to try to do the calculations in a way that we haven't seen before. So there's a lot of creativity that's available, whether you're in design or planning or construction. There'll always be times to think for yourself and to think individually while you apply the principles that have been given to you. If you think your books are cumbersome now, you know, if you become a bridge engineer, the bridge code is about this thick now, you know, so you're going to have a lot of stuff you're going to have to read and learn and know how to reference. Your reference skills are going to be crucial. But there is still opportunities for creativity and creative thought. And to me, that's really the most fun of it, is getting to use the creativity to figure out better solutions to problems.
Any other quick questions? All right.
Oh, I have one question.
Go ahead.
I'm looking for a student who doesn't belong in here. Cassandra? I thought that was you. Okay, thank you. All right, very good.
First off, let's give him a round of applause.
Thanks.
Before everybody leaves, our lab tech had something come up this morning, so he wasn't able to bring sign-in sheets. He's got them now. Sign out before you leave. No late absences and whatnot. That's all I got. Y'all have a good weekend. Let me get this recording stopped.
Oh, yeah.